This video is moving into summation of arithmetic sequences. And so I think you guys remember that summation, we use sigma notation. And so basically you can do these types of problems a couple different ways. One way with your calculator, which since you're at home, this is the way that you are going to be doing it this whole time. You are going to add together dn plus a sub 0. You are going to add together a arithmetic sequence. You can see I just put the formula right there. You are going to start at 1 and end at some other number, and that x value I'm just using as a variable there. It's possible to do this without a calculator. There is another formula. The sum of however many terms you're adding together. This is the number of terms you're adding. Terms being added together. And that formula is n divided by 2 times the first term plus the last term. This is the first term and this is the last term. And I don't want you to be fooled that it's always going to be a sub 1. It's the first term in the summation of what you're adding together. I'm going to show you both ways, but I'm going to mostly focus on this one right here. When it comes up and I find it a little bit easier, I will kind of maybe use the second formula there. So if you take a look at example 6a, it says find the indicated partial sum of the arithmetic sequence. So I want you to look at what they're giving you. They're giving you the first term. Oh my gosh, my pen. The first term, and they're giving you the 100th term. And this is how many of the terms they're telling you to add together. So they're saying add together 100 terms. Now it's really funny that I said I was going to focus on the first one, but this the problem and the way this one is set up actually leads itself to this formula so much easier. So this is basically what it's saying. You are going to add together the first 100 terms of the sequence. Now the thing is, you don't know the sequence. So to find the sequence would be kind of a lot of work, like the way that we did it on the examples before. But since you have the first term and the last term, because that's the 100th term of the sequence is the last term of 100 terms, all you have to do is follow this formula. N is 100, so 100 over 2 times the first term plus the last term. And when you simplify this, you'll get 50 times 322, and that value is 16,100. So I actually think that using the, I'm going to call it like a shortcut formula, is a little bit better on this example. Otherwise, you would have to go back and do all that work on finding the formula and then using the one I bubbled up there. So, you know, it just kind of depends on what they give you. If you take a look at B, example 6b, look at what they're giving me. They're giving me the sequence. They're giving me the first term, the second term, the third term. I automatically, my eyes go right to this because I know that I am going to be able to find the formula really quickly here. I can see that I am adding 4 every time. I'm adding 4, I'm adding 4, I'm adding 4. So my formula is 4n plus I need the 0th term. Well, the 0th term would be the one that comes right before this -6. So to move forwards in the sequence, you would be adding 4, and so to go backwards in the sequence, you would subtract 4, which would make that a -10. So it's 4n minus 10 is the formula for the sequence. And then this number right here, the 50, is what you're adding together. So you are trying to add together the first 50 terms of this sequence. And then remember how to put this into your calculator. Let me pull up my calculator here. I hope you can see this. I actually don't know if you're going to be able to see this because I don't think it's showing my screen, but I do have my calculator pulled up here. I think it's only showing a certain section, but remember how to get summation. you hit alpha window number 2, and it will give you the summation key. And so you say x goes from 1 to 50, and then instead of n, I'm using x in the calculator. 4x minus 10. I wonder if I can bring this over into here. I'm curious. Well, I'm going to hit enter first. The answer is 4,600. Oh, look. Oh my gosh. I'm hoping you can see this now. I don't know. So that's what you would type in. And the answer is 4,600. So that question was basically led to the formula, the very first summation formula that I gave you. Okay. Now I'm going to go to number 3. So number 3, I'm looking at the problem, and I see that they basically give me the sequence. They give me the first 3 terms, and then they give me the last term. The only thing that they don't give me is how many terms am I adding together. And so that's kind of something I need to figure out. So I am going to write my formula. You'll see that I'm going up 5, up 5, up 5. So my common difference is 5 times n. The 0th term would be negative 5. And so I get 5n minus 5. Oh, this pen, that's a minus. I'm going from 1 up to, and this is the part I need to figure out. How do I know how many terms that is? I know 1,035 is the last term, but how do I figure out how many terms I'm actually adding together? So what you do to find n is you just take your formula, 5n minus 5, and set it equal to 1,035. And then you just solve for n. So you would add 5, you would get 1,040, you would divide by 5, and you end up getting 208. So that value that you just figured out is the number of terms that is actually being added together. 1,035 is the 208th term. And then what you guys do is you plug all of that into your calculator again, and when you add all those terms together, you end up getting 107,640. You can use this other shortcut formula if you'd like. You still have to find n. If you're going to do that, you have to find n, and I'll just kind of show you though. So if I wanted to use this formula instead, I would have to have done this part to get the 208. I'm adding 208 terms together. So it would be 208 divided by 2 times the first term plus the last term, which they did give you the first and the last. And that's going to end up giving you the same answer that you found there. So you can kind of do it 2 different ways. I am actually going to skip 7 because we're not going to use a calculator right now kind of in this world. So you could always practice plugging those into your calculator if you wanted to, but I am going to skip down to example 8, and that'll be our last one for today. And again, remember, you can always pause these videos, you can rewind the videos, you can rewatch the videos, so please do that if you are feeling uneasy. All right, so this one, it says 11 rows of logs are stacked on one another to make a pile. So I'm going to do my best to draw a picture of this. And you can giggle and laugh at me because my picture is not going to be good. So this is what, I'm kind of drawing, is logs right next to each other. Oh my gosh. Those are like big logs of like trees that have been cut down is kind of what I want to show you. Oh my gosh. There's a really pretty picture in your book. By the way, I never really draw this good, and I am especially not drawing this good right now. So it says, though, that the top row has 10 logs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just to kind of be accurate. Okay. And then it says, it's growing. This pile is growing. And the bottom row of logs, which I'm not going to draw the whole thing out, but has 30 logs in it. Please work. Please work. Sorry, I'm just trying to, okay, 30 logs. I know that there are 11 rows of logs. So it says how many are in the stack. So basically this is an arithmetic sequence. It's growing by a certain number from row to row to row to row to row. They're giving me how many rows I have. So this is actually a little bit easier to use the shortcut formula. You're adding together the sum of the 11 rows of logs. So you are going to take 11 divided by 2. Remember what goes here is the first term of the sequence. And that is, oh my God, this pen, what the heck is the battery? Sometimes when the battery runs out, it gets like really glitchy. So is 10 plus the last term. And the last term in this situation is 30. And so then all you have to do is take 5.5 times 40. And you would end up getting 220 logs. The other way to do this problem is to try to write your formula. And so you would know that the first term is 10 and the 11th term is 30. And what you can do is do exactly what we do in the other problems, relate the terms to each other. The first term plus 10 common differences is the 11th term. So I would get 10 plus 10d equals 30. Subtract 10. That would give me 10d equals 20. Divide by 2. That gives me the common difference of 2. And then to get my 0th term, I know the 0th term plus 1 common difference is the first term. So the 0th term plus 2 equals 10. And then I would subtract 2 and I would get the 0th term to be 8. So I could do this. I'm adding together the first 11 terms of the sequence, 2n plus 8. That should also give me, oh shoot, I don't have my calculator by me. Boo. I wanted to double check. Oh, actually I have this one, remember? Let me, I don't know if you can see this. I'm going to go right here. I'm going to try to pull this up for you. So just in case you forgot how to do this, alpha window number 2. Oops, I need to get to my equal sign. I would go x goes from 1 to 11 of 2x plus 8. This should, if I did this right, give me 220. Which I know you can't see that, but it did give me 220. Let me see if I can grab it and scoot it over. Oh my gosh. Technology. I love it, but it's not working for me right now. Well, I know you can't see it, but it does say 220. So you could also do it like that. So that's really cool. So either way you want to do it, I really don't care. You need to be able to add together summation of arithmetic sequences. All right, thanks for watching. Please try the rest of your practice page for today.